So as Claude mentioned, my background is in industrial, and the team I'm on at Groom Energy focuses on industrial metering and load management projects. The goal I wanted to go over today was just to give everybody a feel for how industrials use meter data, what they do with the meters, what the needs are in the industry. So typically, why do industrials meter? Historically, industrials have done a very good job with data collection, from front-end office systems to production data to quality data. They're used to handling data day in and day out. But historically, they've ignored utility data. And until recently, they've begun to realize that utility data is a substantial cost, it's an operational cost, and it's something that can be managed. And there's a lot of benefits out of having awareness to the energy data. Usage allocation is one of the key points, being able to understand how many kilowatt hours were used to consume to make a certain product or run a certain line are important. For utility bills, by show of hands, how many people have seen a utility bill that was incorrect? Okay, so we don't see it happen often, but when it does, it's significant. But the last time that happened for me, it was a customer in my home state of Connecticut. They were running under a tariff that stated they had a peak of 1,000 kilowatts, and once they crossed that, they would be moving to a new tariff. Well, they did cross the peak 9 months before we got on site, but they were never moved to the new tariff. And one of the services we do is a tariff analysis, and we compared what they were billed versus what they should have been billed, and it came out to being a difference of about $9,000 a month. So the site took the data and made their case to the utility. Then they got a check back for $50,000. So not a bad payday for taking the time to understand your tariff and look at your bill. So for operations and performance, a lot of sites will use utility data to understand how the facility is running. They will sub-meter to look at individual pieces of equipment, and they'll try and tie energy usage to changes in operations. And last, with industrials, it's definitely a continuing commissioning process. Facilities are constantly changing, adding capacity, removing capacity, things go up and down. So as goes the business, goes the metering. So whatever solution you do put in needs to be something that can be added to, it could be modified, but it has to constantly be looked at. And down below is one of my favorite quotes. This is kind of the CEO mindset. If we have data, let's look at the data. If all we have are opinions, I'll go with mine. So what we're doing with sites is giving them the data to make better decisions on business and have some information to back them up when they try to make their case. Okay, so who's actually using the data? Again, at industrials, there's many audiences that are interested in having data. Internally, maintenance, engineering, they like to have higher resolution data. Accounting is very interesting. We get a lot of requests from accounting to understand what the real-time cost of energy is. In a volatile market, if the cost of energy is changing, it may impact the profitability of what they're running. And it may get to the point where they may want to put a surcharge onto the product based on energy prices. The other challenge for accounting is paying the monthly bill. If they have a good metering system in place, good access to utility data, they have the ability to understand what it's costing on a daily basis so many days into the month. And based on the remaining manufacturing days, they can do a more accurate prediction on what their bill is going to be. Again, this is a big deal for accounting and payroll departments, areas that need to figure out where they're going to be spending their money. Outside of the internal users, utility companies, energy efficiency companies, consultants, they're typically requesting data on a regular basis to understand the impact of their projects. We're seeing a lot of industrials sending data off-site out to dashboard companies, so people are becoming more comfortable putting their data out onto a server for the reason of making it more accessible for others to view it. And even customers are starting to request data along with the products that are being manufactured as part of corporate sustainability. So they want to understand what the impact is on the products that they ordered, and be able to document that as part of their programs. Okay, so there's a few lessons learned along the way I'd like to share. First, temporary metering. It's a great first step. If you can get something up and running, get data in front of a customer at the very beginning of a project, it helps drive the discussion between the need for developing a capital project and doing a more permanent solution. There's a lot of products out there, and you'll see them on the floor today that go on very quickly, provide data quickly. Data helps you make the argument for increasing the scope of that project. The most important thing I would consider from everything on this presentation is developing a bulletproof baseline. Baselines for industrials show a profile of how the facility is running. And facilities that have multiple ongoing projects for energy conservation, they need to understand what they're measuring from. And this is something that needs to be done before the start of a project. The last thing you want to do is complete a project and then have a discussion on how much did we save and what was the baseline. So it's always good to understand what your baseline is, make sure everybody involved in the project understands it, and that it's something that's documented at the facility. Electrical installation, I can't wait for smart meters to be installed. Right now, when we look at a utility meter, the typical cost is $300 to $500 to get a pulse output that says you've used so many kilowatts. Simple contact, which doesn't sound like a lot to install. But at a large industrial site, that could require lots of wire, conduit, electrical work. If the meter is out across the backside of a field or in a utility-owned substation, you can spend a great amount of money just to get a simple pulse out of a meter. When smart meters are available, and we can get to that with a communication link, it's going to make life a lot easier, and the quality of information is going to be much better. So resources for analyzing data, that's another important thing to make sure is in place. Collecting 90 days of 15-minute data and putting a CSV file in the lap of somebody doesn't really do any good. That's just data. And the goal, you need to turn data into information. Information's going to turn into insight. You need to make sure their resources are in place to do that. If they're not in-house, there's a lot of companies that will do that as a third party. But part of any metering project is making sure you know who's going to handle the data, what's going to be done with it, it's going to be turned into something that provides value. And last is documenting and simplifying, summarizing the savings for management. And again, management is not going to want to look at multiple days of CSV data. They want a simple key performance indicators, a scorecard, something simple that shows what the value is, what's being learned from the meter data. Okay, so where's the opportunity at facilities? We've talked a lot about smart meters on electric. So the main utilities, electric, gas, water, these are all things that should be monitored. Where industrial sites are a little different, they generate a lot of their own utilities. So compressed air, steam from boilers, chilled water, these are all created on site using electrical energy from the utility. So they're natural targets to be metered. In addition, major loads on the distribution side can be looked at, large motors, anything that really consumes energy that can be used to manage down the cost. Those are the best targets. Okay, now this slide's a little busy. I'm not going to go through every step. This just shows how most industrials think. A lot of work at industrials, it's decision by committee, multiple stages, before, during, after. So if there is a metering project that's occurring, it's important to know, is there a energy management strategy in place? Where does the metering fit in, before, during, after? A lot of times these pieces are missing from sites we work at. We'll try and fill them in if it's going to help the project be more successful. But more often than not, there are measures like this in place, and it's just important to understand where you fit in. Make sure you're talking to the right people and working with the right teams. Okay, so a few different levels of metering, just wanted to review. Temporary, we talked about, it's a great first step. It goes in quickly. It's usually the first solution, and sometimes it's the only solution. So if you take like a lighting project, for example, you may be changing a couple hundred bulbs, and you're going to meter a couple of weeks before, you're going to make the change, you're going to meter for a couple of weeks after. Once that project is done, the lighting's still going to run the same as it did before, it's just at a different level, so there's really no need to do ongoing metering. So that's a good argument for a temporary metering project. When you go into longer term projects where conditions may change and you want to keep watching those loads, permanent metering is the next best step. The downside of that is it requires a more formal installation. It'll take longer to install and become operational. But the upside is, in cases with permanent metering, you can set up a system to provide real-time information, or you can send it to a database for historical, or if there's other systems inside the facility that can benefit from sharing that information, you can tie systems together. So temporary is good just to establish its value. Permanent is better if it's going to be an ongoing process. Like I said earlier, we saw more companies moving to a web-hosted application. So once you collect the data, you can either keep it on-site and work with the data, you can move it off-site. There's a lot of good third-party companies out there that will accept your data, put it into their databases, give you some nice tools for reporting and viewing the data. The access is usually through simple web servers without any additional software. So there's a lot of good arguments to be made for looking at a web-based solution. And then, like anything at industrials, there's no set rule. There's all different combinations of the above. You may see all three of these at one site. It's very common. Okay, so in a typical architecture, let's just start from the bottom up. Across the bottom are all the typical loads that are usually monitored. So utility meters, transmitters, pieces of equipment. And the one thing with those is each device has a different way of communicating. Right now, utility meters are pulses. Like I said, I can't wait for those to be smart meters and be able to communicate with those directly. But for each device you're talking to, there's going to be a different way to communicate to it. And the one key thing is to get all the data into one place. So if you've ever tried to look at batches of data from different sources and line up dates and timestamps, it's a lot of manual work. Collecting all the data to a single place and then pushing it into a database all at once, it makes a lot of sense. So sites will typically collect all their data into one acquisition server. That could be a standard process controller that's used in facilities. It could be a custom piece of equipment that goes in. From there, it can be shared with other systems. So it can be sent to a local database for real-time historical data viewing within the facility. It can be pushed off-site to a data acquisition server. There's a lot of choices, but this is typically something along the lines of what we normally see for industrial. Okay, and just to give some examples of what facilities do with the data. Before working at Groom, I had worked at a company that did demand reduction projects. So we went to industrials, we reviewed tariffs, we looked at usage profiles, and this is what we would typically find. What's showing there is an example of kilowatts over time, and this was a facility that had electric arc furnaces melting steel. So 3 furnaces ran in 30-minute cycles, and just like the aligning of the planets, once in a while they would all hit at the same time, and suddenly you're at your 15-minute peak for the month. So what the project consisted of was monitoring the energy usage real time, monitoring during the interval of what was happening with the facility, and even 7 minutes into a 15-minute interval, if you could detect that you were going to be using more energy that's going to drive you to a new peak, systems would back off, or you would shut down other systems, and trying to reduce that profile just for that interval, the overall effect is lowering your peak demand. In this case, they were able to drop 800 kilowatts off of their peak. Savings were about $6,300 a year. So definitely a great use for metered data. Okay. Another example, air compressors are a pretty standard load for us to work with. This was a case where we had been asked to put metering on air compressors to help develop operational costs. They just wanted to know how many kilowatt hours were consumed over the month and what it cost them to run the units. But something else that came out of the data was on the graph on the left, there's two lines, or a blue and a red, for two different compressors. One of the units was running fairly normally as a baseline. The other unit was coming on very randomly once in a while just to make up for small gaps in pressure required. And when we see something like that, it's a sign that the second unit, it's coming on, but it's just on the verge of not being needed. So we made some changes to piping, we adjusted set points, and we were able to get that system to the point where, as shown on the chart on the right, only one unit was running. And you see a switch halfway through that chart because since only one unit's running, they decided to rotate and kind of share the work between the two. But the overall savings were a reduction in kilowatt hours, a reduction in peak, a reduction in units starting and stopping, which can be a maintenance issue. So there's a lot of different revenue streams for savings. And it started as just monitoring the unit for cost, but by looking at the data and drilling down, there were a few other opportunities. Okay. And this screen is similar. It's another example of looking at air compressors and energy usage. In this case, the site had 3 mechanical rooms spread across the facility with multiple units in each room. And again, they had requested metering just for the operational costs, monthly costs. And until they had that, they had never understood, had the ability to see at one place exactly what units were running, how hard they were running. And there was one point in time where, due to a set point issue, multiple units were shutting off at the same time when they shouldn't have been, and the remaining units were tripping out in an alarm because they were trying to work too hard. So the utility metering, while it still provided the monthly cost, it gave them a little more insight into how things were running during that month and helped out with the units. Okay. This slide is intended just to show how data is presented. What the two graphs show are different views of data for the same unit. And I'm going to pick on air compressors again because that's what we work with in many cases. The upper trend is something an engineering team would like to see. So that's a trend that shows pressure flow relating to kilowatt hours. So they would look at that data to try and understand how the unit is operating, when it's coming on, when it's coming off, really troubleshooting to a fine detail what's happening. The trend below is something that management may use. So this is a trend called CFM per kilowatt. And what it really means is how much air is being generated by my air compressors, how much energy is being used to generate that air. So it's a ratio between the two. And whether you have 1, 2, 3, or 5 air compressors running, that number should be about the same. And what it provides management with is a baseline. And they can answer the question, is my plant running the same as it was? Is there a change? Or how is my baseline on CFM per kilowatt compared to another factor we have in another state? So it gives just an overall view. Are we doing the same? Are we doing better? Are we doing worse? How do I compare? Again, 2 different views for the same type of asset. Because of this, as a practice, we will normally run through an exercise when we do metering to list all of the possible points we can look at and determine who's going to be looking at the data and what parts of the data do they need to see. So in this case, there's 3 columns, one for engineering, one for management, one for a scorecard that was being developed. And when we think about smart meters on utilities, we're going from a contact that closes to kilowatt hours to how many parameters? There's
We have 4 at least.
Yeah, so some meters I've seen 70, I've seen 80.
Yeah.
So you have volts, amps, VARs, power factor. There is a lot of data that's going to be coming from those meters.
Flow direction, quality.
Yeah.
I mean, we use it for half an hour.
It's going to be wonderful, except it's going to be like drinking from a fire hose. You're going to have a lot of information, and you're going to need to figure it out who is going to see what, who's going to find value out of it. And just presenting everything to everybody isn't the solution. You really need to think about who's going to see what and how they're going to use it. Okay. And last, we mentioned scorecards. Everybody likes to know the score. You know, the examples on the right, I'm thinking of a baseball game. You know, not only are you at the game watching it, some people are listening on the radio at the same time. Some people are reading updates on their phone. You've got the person keeping score with the book in their lap sometimes. You've got scoreboards for each player, for the pitcher, for the other teams in the league. So people generally like to know what's going on. Same thing with energy. So a good scorecard will take that meter data and quickly summarize it and just show, are things getting better? Are they getting worse? How do we compare? For a lot of companies that hold weekly, monthly, quarterly energy meetings, these are the start of a lot of conversations. So whenever you're doing metering or getting data from things like smart meters, it's good to review what can you possibly get and what's going to make sense to summarize. Okay. And that is the end.